Hello dear students, very good morning to all of you. Up till now we have studied two elastic constants. First one is Young's modulus, which is related to the changes in length. So it is the ratio of tensile stress to the tensile strain. We have derived its formula. Y is equal to mgl upon pi r square L. Then the second elastic constant, which is related to the changes in volume of the body, and that is called as bulk modulus. It is denoted by letter K, and it is the ratio of volume stress to the volume strain. We have also derived the formula for it. Then the remaining elastic constant that we have to study now, this is the third elastic constant and is named as modulus of rigidity, and symbolically it is denoted by this symbol, which is called as eta. As we have studied, Young's modulus is related to the changes in length, bulk modulus is related to the changes in volume. Then the modulus of rigidity will give the relation between shearing stress and shearing strain, because it is related to the changes in shape of that body. So whenever the deforming forces are applied to the body, and because of that forces, if there is a change in shape of that body, we say the stress or strain associated with that, we call them as a shearing stress and shearing strain. Then as you know, whenever we have to find any type of stress or strain, we have to consider their definitions. So by the definitions of elastic constants, we can say the modulus of rigidity will be the ratio of shearing stress to the shearing strain, because shearing stress and shearing strain, they are related to the changes in shape of the body. So for that we have considered the example of a cube or a block whose height or length is L, whose surface area of each side, that is A suppose, and if the force of magnitude F is applied tangentially to the upper surface of the upper layer of this cube or this block, while the base of this block or cube is fixed, then what happens? Because of this force, since they are applying tangentially to this surface only, because of that this surface will get shifted and there is a change in the shape of this block. So we say this force per unit area of cross section of the surface gives us the shearing stress which is produced in the block, because of that force which is applied on this surface, the shape of the cube changes. Whenever there is a change in shape, we say that there is a shearing stress, and that shearing stress, if we have to find, we have to take the ratio of applied force per unit area of cross section. Now here it is, the forces are applied tangentially, and the force which we apply perpendicular to the area of cross section, that is different than these forces. These tangential forces produces the change in the shape of that body, and because of that this shearing stress, we can have the formula for that. According to the formula, we know it is the applied force to the area of cross section. Here it is, the applied force is F, area of cross section for this space of the cube is A. So we say shearing stress is equal to force upon area. Here it is, we have said A is the uniform cross section of the block, L is the height of the block, F is the magnitude of force which are applied along the top and bottom surface of the cube. Here it is, the bottom surface is fixed, only the forces are applied to the top surface, and because of that the top surface is get shifted, there is a change in the shape of the cube. So now we get the formula for shearing stress is equal to force upon area. How can we calculate the shearing strain? Since the strain is the ratio of two similar quantities, And here it is, because of the application of deforming forces, the length of the cube get changed. Because of that, we have said that here it is the length of, since it is the cube or block whose each side is of length L, this side of this cube also gets changed, also gets deformed, and there is a change in length of the cube that we have denoted by delta L. So whenever there is a change in length of that object, the strain associated with that, we call it as a shearing strain. So whenever you have to calculate strain, you know the definition of strain is what? Change in dimensions upon original dimensions. If it is related to the change in length, which definition we consider? It is the change in length, that is delta L, divided by original length, that is L. Shearing stress, force upon area. Shearing strain, change in length upon original length. So eta, that becomes F into this L will get to this side, divided by A into delta L. This is the formula which we get to find the modulus of rigidity. Eta is equal to force applied to the length divided by its area of cross section into the change in length. As you know, the Young's modulus, bulk modulus or modulus of rigidity, all of them, whenever we have to find them, we require the same formula, that is basic ratio of stress to strain. So SI unit for this modulus of rigidity is also same as that of the unit of stress, and it is SI unit is what? Newton per meter square. If you have to find its dimensions, you have to find the dimensions of stress. And also one thing you have to remember here, that this modulus of rigidity, it is related to the changes in shape of the body, and only the solids are having definite shape. Liquids and gases do not have definite shape, and therefore this is the property which is possessed only by solids. For liquids and gases, we can't define modulus of rigidity. So remember one thing, Young's modulus and modulus of rigidity we can define for solids. For liquids and gases, we can't define Young's modulus as well as modulus of rigidity. But bulk modulus is the property for solid, liquid and gases. So there is a question for 1 mark. Define modulus of rigidity. Write unit and dimensions for the modulus of rigidity. Once you follow the basic definitions about the stress and strain, easily you can write the formulae for each of these elastic constants. So these are the 3 elastic constants which we have studied now. Then we have to discuss another article we call as a Poisson's ratio. In order to study the modulus of rigidity, when the forces are applied, the magnitude of force F applied at the top and bottom surface of the cube or block, by remaining this block, bottom of the block is fixed, if the forces are applied only on the top surface, that will get shifted by a small amount delta L. Because of that, there is a small change in the corresponding angle, that is equal to theta. From figure, if you observe the figure carefully, this delta L upon L, if this ratio we find, this gives us the value for tan theta. So tan theta will be equal to delta L upon L. But we know delta L upon L is what? Shearing strain, change in length upon original length. From this figure, this delta L upon L is equal to tan theta. Since theta is very small, this angle is very small because the displacement is also small. So tan theta is equal to, we consider only theta. So delta L upon L in this equation can be replaced only by theta. So we get another formula for the shearing stress, for the modulus of rigidity. Eta is equal to what? Shearing stress is F upon A, while this delta L upon L, this term we can replace by simply theta. So shearing strain in terms of modulus of rigidity, we have to take it is in terms of angle, and that is equal to theta. So the formula we can write eta is equal to F upon A divided by theta. So it becomes F upon A theta. Remember this formula, which gives us the modulus of rigidity. Constants, Young's modulus, bulk modulus and modulus of rigidity. We study the next article from this chapter, that is Poisson's ratio, which is denoted by this letter named as sigma. Question for 2 to 3 marks on this article. Define Poisson's ratio. Obtain the formula for it. Write the unit and dimensions for Poisson's ratio. So for that we have taken these examples. See here. When one wire is taken whose original length is L and its radius is R. If the wire is suspended from the rigid support and to its lower end if we apply some force, what will happen? Because of this force, the length of wire increases. When the length of wire increases, we say there is a longitudinal strain or tensile strain. Means there is a change in length of this body. There is change in length of the wire. This is also called as the linear strain, which is produced in the